Our story begins over 4.5 billion years ago. Imagine a vast cloud of gas and dust, remnants of a long-gone star. This cloud, called a nebula, swirled and churned, pulled together by an invisible force, gravity. As the cloud contracted, it spun faster and faster, like a cosmic dancer. At the center of this swirling mass, a star began to ignite our sun. The sun's birth was a dramatic event, releasing immense heat and light. This energy pushed outward, shaping the remaining gas and dust into a swirling disk. Within this disk, small particles began to clump together, drawn to each other by gravity. Over millions of years, these clumps grew larger, pulling in more and more material. This process is called accretion. As these objects grew, their gravity intensified, pulling in even more material and growing even larger. Eventually, these growing bodies would become the planets we know today. One of these growing bodies, a fiery ball of molten rock and metal, would eventually cool and solidify to become our home, planet Earth. It was a violent and chaotic birth, but from this fiery beginning, the stage was set for the incredible story of Earth to unfold. The early Earth was a far cry from the planet we know today. Imagine a world of intense heat with rivers of molten rock flowing across its surface. Volcanoes erupted violently, spewing lava and gases into the primitive atmosphere. The air was thick with noxious fumes, making it impossible for life as we know it to exist. This period of intense heat was due to the energy released from the numerous collisions during Earth's formation. As objects crashed into the young planet, their kinetic energy was converted into heat, melting the surface and creating a global magma ocean. The constant bombardment from space also prevented the Earth from cooling down. Large asteroids and comets, remnants from the solar system's formation, rained down on the young planet, releasing even more heat and energy upon impact. These impacts were so powerful that they could vaporize entire oceans. It was a truly inhospitable environment, yet beneath the fiery surface and amidst the chaos, the stage was being set for the next chapter in Earth's incredible story. Deep within the Earth, a solid core began to form, setting in motion processes that would eventually lead to a more stable and habitable planet. While the young Earth cooled and solidified, a dramatic event occurred that would forever shape our planet, the formation of the Moon. Scientists believe that a Mars-sized object named Theia collided with the Earth in a colossal impact. This impact was unlike anything Earth has experienced since. The energy released was unimaginable, melting Theia and ripping a significant portion of Earth's mantle into space. Debris from the impact, a mixture of molten rock and vaporized material, was flung into orbit around the Earth. Over time, this debris coalesced under the force of gravity, gradually forming a ring of material around the Earth. This ring, glowing brightly in the early solar system, slowly clumped together, drawn by the relentless pull of gravity. Finally, the debris consolidated into a single spherical body, our Moon. Initially, the Moon was much closer to Earth than it is today. Its gravitational pull was much stronger, creating immense tides and influencing the Earth's rotation. Over billions of years, the Moon has gradually drifted further away, its influence waning, but still shaping our planet in profound ways. Section 4, a breath of fresh air, Earth's early atmosphere. As the Earth continued to cool, a new chapter began, the formation of our atmosphere. Gases trapped within the Earth's interior during its formation began to escape through volcanic eruptions, a process called outgassing. This early atmosphere was drastically different from the air we breathe today. It was composed primarily of gases like nitrogen, carbon dioxide, water vapor, methane, and ammonia, lacking the life-giving oxygen we depend on. This toxic mix created a dense, hazy atmosphere, trapping heat and contributing to the planet's extreme temperatures. Despite its inhospitable nature, this early atmosphere played a crucial role in Earth's development. The presence of water vapor released during outgassing and delivered by icy comets allowed for the formation of the first oceans as the Earth cooled enough for water to condense. These oceans, initially shallow and warm, would become the cradle of life. Over billions of years, the atmosphere would undergo dramatic transformations driven by geological processes, biological activity, and the relentless power of the sun. Ultimately, this evolution would lead to the oxygen-rich atmosphere that sustains life as we know it today. Section 5, Life Finds a Way, the first organisms. In the warm primordial soup of Earth's early oceans, a miracle occurred. Life emerged. The exact details of how life arose from non-living matter remain a mystery, but it is thought to have involved a complex sequence of chemical reactions. These first life forms were simple, single-celled organisms, similar to bacteria. They thrived in the harsh conditions of the early Earth, relying on chemosynthesis to obtain energy from inorganic compounds. This process, unlike photosynthesis, which relies on sunlight, allowed these early organisms to thrive in the depths of the oceans far from the sun's reach. Over millions of years, these simple organisms evolved and diversified, adapting to the changing conditions on Earth. Some developed the ability to photosynthesize, using sunlight to create energy and releasing oxygen as a byproduct. This marked a turning point in Earth's history. The gradual accumulation of oxygen in the atmosphere, a consequence of photosynthetic life, paved the way for the evolution of more complex life forms. This oxygen revolution would transform the planet, ultimately leading to the diverse and interconnected biosphere we see today.